Alright guys, we're going to finish this up. There's only a few more that we have left on the note sheet from yesterday. So we're going to finish up these rational expressions, and then I'm going to give you the rest of the time to work on any of the worksheets or other assignments you haven't finished yet. Now when we look at these rational expressions, these complex fractions, what we're trying to find is the LCD, the least common denominator, that we can multiply the top and bottom by, so that all the fractions inside this fraction will simplify out. Yes. Well, looking at this here, the only two terms that actually have a denominator inside this fraction is the 3 over x plus 4. In the denominator, we have 2 over x plus 4. Well, the denominator for both of these here is x plus 4. So if those are getting multiplied by the x plus 4 will actually cancel out. Because when we do this multiplication, erase that, we multiply by the numerators of each one here. So the x plus 4 is going to be multiplied with the 3, which would give us 3 times x plus 4 over x plus 4. Minus, well, we have to multiply it with the negative 2, so we'd have negative 2 times x plus 4. We'll do the exact same thing for the denominator. The x plus 4 times 5 to be 5 times x plus 4. Plus, here the x plus 4 is going to multiply with the 2. We'll have 2 times x plus 4 over x plus 4. Any questions on this so far? Some of y'all a second to write that. Now, what simplifies? Well, these x plus 4s and these here, which will leave us with what? 3 minus 2 times x plus 4 over 5 times plus 4 plus 2. Well, we will have to multiply through and simplify, because there's a chance that we could have something that simplifies or something in common on top and bottom. So in the numerator, we're going to distribute the negative 2. So 3 minus negative 2 times x would be negative 2x. Negative 2 times positive 4 is going to be negative 8. In the denominator, we're going to distribute the 5. 5 times x would be 5x. 5 times 4 is going to be plus 20 plus 2. So in the numerator, we would have, well, negative 2x, because there are no other x terms in the numerator. And the 3 minus 8 would be negative 5. The denominator, well, 5x does not have any like terms, plus 22. Now there is a negative 1 that we could factor out of the numerator, but besides that, is there any greatest common factor between our 2x and 5? Is there any greatest common factor between our 5x and 22? That's it. Any questions on this here? All right. Let's look at this one here. So we need to multiply the top and bottom of this complex fraction so that the fractions inside of it on top and bottom will officially simplify. So what's one thing we know we'll need to multiply the top and bottom by? Because the x plus 1, put a highlighter, will simplify these two denominators here. Do we need anything else? Because the x would simplify those two there. So the least common denominator for this here would be x times x plus 1. And again, we're going to multiply the numerators by this. So the first one, x times x plus 1 times, well, our x times x is x squared times x plus 1 minus x. Well, we're going to have 1 times x plus 1, which will just be x times x plus 1. In the denominator, again, we're going to have x times x plus 1 times x, which is just going to be x squared times x plus 1 over x plus 1. And lastly, x times x plus 1 times 1 is just going to be x times x plus 1. Now, luckily, there are some things that simplify, and, well, we expected there to be so. Because this x plus 1 and x plus 1 would cancel. Here, the x plus 1 and x plus 1 would. Here are x and x, here x and x. Right, we'd have x squared minus, and on bottom we'll have x squared plus any questions on how we got to this point here? Because of the addition and subtraction signs, it's sticking them together as one whole term. So we're considering this as an entire term and this one here as an entire term in the denominator. They're connected to each other. See here. I think a better example to look at would be, say, because we do good with fractions, or not great with fractions, but we're better with numbers than we are with variables. Because if we look at this here, can I say that this 2 and this 4 here, we can simplify down to 1/2? So if we do that, it would be saying 1 plus 3 over 2. Well, 1 plus 3 is? 4 over 2 is? So let's go on and add them first. 2 plus 3 is? Because these here, the 2 and the numerator are connected together. Because what we're saying realistically with this, back up all the way to here, is that this is the same as 2/4 plus 3/4 that we're adding together. Because 2/4 plus 3/4, 2 plus 3 is?
So that 2, that's not what you do.
Because if I did that, I'm not just changing this here, but I'm also scaling this one down without actually scaling the numerator because of that addition-subtraction connection. Here, with the plus on bottom, it would be the equivalent of saying, kind of going back, that we have 4 plus 3, or not 3, let's say 7 on bottom, and just trying to simplify the 2 and 4. Because here, if we had 4 plus 7 on bottom, trying to just simplify the 2 and 4 would actually change the entire demographic or change this entire fraction. Does that kind of make a little more sense? So whenever we look at these here, we really need to simplify to multiplication, because when we have two things being multiplied, we can split them apart and put them back together quite easily, like we've been doing the last few days, because multiplication, we multiply on top, they're next to each other. So here the numerator is going to be x squared. Well, the negative is distributed through, which gives us negative x minus 1. The denominator is x squared plus x plus 1. Will either one of these factor? We can check with the square root of from the quadratic formula, because we know for this to actually work and have factors, this needs to come out to be a whole number and positive. Well, our value b for the numerator is negative 1 squared minus 4 times a times c. Well, 1 squared is 1 plus 4 is the square root of 5. Square root of 5 does not have a square root. So, okay, the numerator doesn't factor. Now, the denominator will almost be the exact same thing except for those two spaces. So we would have positive 1 and positive 1 here. Well, 1 squared is still 1 minus 4, which would be the square root of negative 3. Still, we do get a negative number, because it really didn't matter if it was 3 or 5. Since it is negative, we have complex solutions. So it actually works out that neither one of these would work. We can't factor them. And especially if we have 1 and 1, because as we've seen, the constant terms, when we just have x squared, really add together or subtract from each other. So if we have plus and plus, so they're adding together, if it were to factor, we need the middle term to be a 2, because 1 plus 1 would give us 2. And if it's subtracting, or opposite signs, well, we actually couldn't have a middle term with a factors of 1. So that's as far as we can go. Questions on this here? How do we feel about these here? We feel pretty comfortable with these here? Yes, let's do this one and one more, and then we'll actually be done for the day. And I think there's actually 2 left. I put these together, but I don't always remember the total number that we have. So, this one here, what would we multiply the numerator and denominator by? Anything else? Well, no, that's the only denominators that we have in the numerator and denominator is the 2x minus 1. Now, if we multiply this through the top, well, the 2x minus 1 times 2x, we will have 2x times 2x minus 1. Minus what? Because if we do feel comfortable with the fact that those will cancel, we can write it as 2. Because if it's still a little funky jumping straight to there, there's nothing wrong with having 2 over 2 times 2x minus 1 over 2x minus 1. Because writing it out is helpful for some to be able to keep it all straight. And if that is helpful, go on and write it out. But if you can see that these are going to cancel and leave us with just 2, that works as well. Now the denominator is going to be 3x times 2x minus 1 minus, well, we can either put what? 3 by itself, or Because we can write it as just 3 and leave it as that, because the others will cancel out. Or we can write in the 2x minus 1 over 2x minus 1, because these here will cancel. Almost. Well, we do know that we'll have the minus 2 and minus 3. Now we can go on and multiply the first two. We can multiply 2x times 2x minus 1. Well, 2x times 2x is 4x squared minus x minus 2. The denominator, 3x times 2x is 6x squared minus 3x minus 3. Yes, there is a greatest common factor in both, because the denominator would be, the numerator would be 2. And let's see what that leaves us with. 2 out of 4x squared is x minus, and if I factor a 3 out of the denominator, we're left with, okay. Then we could factor, yes? Do I need to factor these? Because, I mean, we could, and we would get the exact same factors, yes? But anything divided by itself is 1. And we could cross these out and be left with 2/3, yes? Now, I'm going to show this step here kind of, it's probably going to make some of the simplification a little bit more understandable. Because when I multiplied two fractions together, we multiply the tops with the tops and the bottoms with the. So when we simplify, really what we're saying is that I have 2/3 times the 2x squared minus x minus 1 over. Because with multiplication, I can break it apart like this here. Multiplication, we can put them together and break them apart really easy into different factors. Well, we know that this entire thing is going to simplify to 1, which is really just telling us that this is 2/3. Addition and subtraction, we can't just break them apart that easily like we can with multiplication. That's why we can't do that simplification when it's adding two together unlike when we have multiplication. That's really the key behind it. And we get kind of stuck on the fact that, well, since they're the same on top and bottom, we can cross. This is really why we're able to do that. And instead of rewriting it out like this, we're normally used to going here. Well, if it let me stay. Nope. At this point here and crossing those two out and just jumping straight to 2/3 here. Now, this here is the last one we're going to look at. Interestingly enough, 2x squared minus 7x minus 4 actually factors to 2x plus 1 times x minus 4. So, what are our denominators for this here on top and bottom? Well, we have two x minus 1 and 2x minus 1, as well as x minus 4 and x minus 4. Yes, 2x plus 1. So again, this one works out to be these two multiplied together. Now at this point here, we're going to multiply this by each one of the numerators. So the first one, if we wrote this out, well, let's actually talk through the first one because we will have a 3, yes? The denominator 2x plus 1 would cancel out with the, leaving us with n minus 4.
Would that one cancel that over that?
So the top one here, so we're multiplying the 3 by the 2x plus 1 and the x minus 4. The 2x plus 1 and the 2x plus 1 would minus 4 and times the 3. Now with the middle one, the 3x, well this time the x minus 4 and the x minus 4 would cancel, leaving us with because they would cancel out completely. Let me unlock this and grab all this and move all this down. Lock in place. So, yeah. So we're multiplying each one of these by the 2x plus 1 and the x minus 4. Here, these would cancel, leaving me with the 3 and x minus 4. Here, the x minus 4 and x minus 4 would cancel, leaving us with just this here. And as we saw, these are the same, which gets us down to here. Now we'll do the same thing with the denominator. So this here is multiplied by the 2x plus 1 times the x minus 4. And this here is multiplied by 2x plus 1 and x minus 4. Well, here the x minus 4 and x minus 4 would cancel out, leaving us with plus 2 times, well, now we're kind of shortcutting that a little bit because we did show you, because I showed you all a minute ago, that the 2x squared minus 7x minus 4 is those two broken apart. So we can put them back together. Now the numerator, we do have to multiply through and distribute. 3 times x would be 3x minus 12. 3 times 4 would be 12. Negative 3x times 2x is negative 6x squared. Negative 3x times 1 would be negative 3x minus 27x. Now the denominator, 3x times 2x is 6x squared. Yep. Let's see here. A little bit, mainly because I don't know what's causing it. Because 6x squared (3x times 1 would be plus 3x, plus 5 times 2x is going to be 10x plus 5. Plus, here we're just multiplying by 2, so we get 4x squared minus 14x minus 8. So the numerator would have negative 6x squared. These would cancel, yes, minus 27x. Yes. So 10x squared minus x, because 3x plus 10x would be 13x, minus 14x, negative 1. And 5 minus 8 is negative 3. So we could factor out a 3 on top, but I would also factor out a negative 3, which would be 2x squared minus plus 9x plus 4. Now the denominator will factor. Since the 3 is negative, our signs are going to be opposite. One's going to be positive, one is going to be negative. Now the factors of x squared are x and x. 5 and 2 and 2, and then we would have 3 and 1. So let's check it, because this seems a little funky, yes? 5x times negative 1 would be negative 5x. 3 times 2x is plus, which would give us a positive x, so yes. So we would need to switch the signs. Did not need to erase that, because this should be negative and this should be positive. Now, what we're hoping for is that one of the parentheses on top is either going to be 2x plus 1 or 5x minus 3. Which one do we know it's not going to be? Yeah, because 2x squared is our first term, yes? So either 2x and x is the only setup, so there's no way I can get 5x. So we know the signs are going to be the same, because 4 is positive and the middle term is positive. Factors of 2x squared are 2x and x. Now the factors of 4 are 1 and 4 or 2 and 2. Which one do we want? 1 and 4, and we want the 1 with the 2x and 4 with the x. And if we check this here, 2x times 4 is 8x. 1 times x is x, which gives a total of, which means these here would cancel out, telling us that we have negative 3 times x plus 4 over 5x minus 3. And that's it. Questions on this here? And that one there was a bit tedious. Yep. There you go. You're welcome. You're welcome. Four.